Hello everyone, in this video we are gonna see some of the important compounds of tin. Okay, so the heading would be compounds of tin. Okay, SN. Basically tin in the compounds of tin we are gonna see some of the oxides and chlorides of tin. Rest other compounds are not important and also not in your syllabus. Okay, so the first compound which we will see is the stannous oxide. Okay, the formula for stannous oxide is SNO. Okay, so first thing which I wanna tell you is that whenever there is us, okay, then the oxygen state is +2. Okay, and whenever there is ic, like stannic, if there is stannic, then tin would be in +4 state. Okay, but since it is stannous, therefore SN or the tin would be in +2 state. In stannic oxide, okay, the formula for stannic oxide is SNO4. Okay, sorry, SNO2. I'm sorry, the formula for stannic oxide would be SNO2 and tin would be in oxygen -2 and tin would be in +4 state. Okay, we will also see stannic oxide, but first of all stannous oxide. Okay, so another important thing is that tin is amphoteric. Tin is amphoteric. Okay, so its oxides also are amphoteric in nature. Okay, so stannous oxide is amphoteric in nature. Okay, the reactions of stannous oxide with acid and bases are as follows. SNO, when reacts with acid, that is hydrogen plus, it gives SN2 plus water. Okay, so here SNO acts as what? Here SNO acts as a basic oxide. Okay, now when SNO reacts with OH minus, okay, when SNO reacts with OH minus, it forms SNOH whole 6 4 minus. Okay, or this is also, you can write this as, if you remove water, SNO2 2 minus. Okay, so in this case tin acts as a stannous oxide as a acidic oxide. Okay, because it reacts with OH minus. Okay, so basically the important point to remember over here is these two reactions, and that stannous oxide is amphoteric in nature. Okay, the next we would see is stannic oxide. Okay, next we are gonna see is stannic oxide. Okay, stannic oxide I already told you the formula SNO2, and SN is in +4 oxidation state. Okay, like stannous oxide, stannic oxide is also amphoteric in nature. Okay, it is also amphoteric in nature, and its reaction with the acids and the bases are as follows. Stannic oxide, when reacts with acid, that is 2H plus, it gives again SN4 plus water. Okay, when it reacts with base, SNO2, when it reacts with base, that is OH minus, it gives SNOH whole 6 2 minus. Okay, or SNO3 2 minus. Okay, so the basic difference in stannous and stannic oxide is their oxidation state. Okay, here it forms SN2 plus, here it forms SN4 plus. Okay, here it forms SNOH whole 6 4 minus, here it is 4 minus, and here it is SnOH whole 6 2 minus. That's all. This is what you need to remember, and both are amphoteric in nature. Okay, the third compound which we are gonna see is stannous chloride. Okay, stannous chloride. So what would be the formula of stannous chloride? If it is stannous, then tin would be in +2 oxidation state, and the formula is SnCl2. Now it absorbs water to form SnCl2.2H2O. Okay, so this is the formula for stannous chloride. The important property about stannous chloride is that it is a strong reducing agent. It is a very strong reducing agent. Okay, the reaction depicting this value is as follows. Okay, this reaction is important. Reaction with Hg2Cl2. Okay, so what happens in this case is that when SnCl2 reacts with Hg2Cl2, okay, so SnCl2 first reduces HgCl2 to Hg2Cl2. Okay, it first reduces HgCl2 to Hg2Cl2 and itself gets oxidized to SnCl4. Okay, now okay, so this happens. Now Hg2Cl2 when further reacted with SnCl2, okay, it reduces Hg2Cl2 to mercury. Okay, what you get is mercury over here, and itself gets oxidized to SnCl4. Okay, and this mercury is what? This mercury is black. So black precipitate, you can say, would be obtained when you carry out these reactions. And this shows that SnCl2 is a very strong reducing agent, because it first reduces HgCl2 to Hg2Cl2 and then Hg2Cl2 to pure mercury. Okay, so this is an important reaction. The next important reaction for stannous chloride is that it hydrolyzes partially in water. Okay, it partially hydrolyzes in water. Okay, the reaction is as follows. SnCl2 when reacted with water, it forms SnOHCl, okay, plus HCl. Okay, now this, it is a weak base, okay, and this, it is a strong acid. Okay, so this overall solution, okay, this overall solution, what this would be? This would be acidic in nature. Okay, this solution would be acidic in nature because this is a weak base and this is a strong acid. Okay, now the next compound is the stannic chloride. Okay, you would see now stannic chloride. The fourth compound. The formula for stannic chloride is obvious. It would be SnCl4. Okay. Now, the only important fact about stannic chloride is its hydrolysis with water. Okay. So, the reaction of stannic chloride with water is as follows. SnCl4 when reacted with H2O. Okay. It forms SnOH whole 4 plus HCl. Okay. So it hydrolyzes to form SnOH44 and HCl. But this SnOH44, okay, this reacts with HCl itself, okay, to form, again, it gives back this thing. So basically, this hydrolysis, you can say that this hydrolysis is partial again. Okay, partial, or you can say incomplete. Okay, because what happens is that this reaction, it may proceed this side and it may proceed this side also. Okay, now the important point about this is that when in this meantime, it can also happen that SnCl4 reacts with HCl. So when SnCl4 reacts with HCl, it forms H2SnCl6. This is an acid and it is called cetanic acid. Okay, so you need to remember this fact only. Okay, so what we saw in this video we saw that there is stannous chloride. Whenever there is us, there is tin is in +2 state, and whenever there is ic, then tin is in +4 state. Okay, stannous oxide and stannic oxide both are amphoteric in nature, and we saw their reactions with acid and base. We saw stannous chloride and saw that it is strong reducing agent, and when reacted with Hg2Cl2, it gives pure mercury. Okay, it partially hydrolyzes in water to form a acidic solution. Okay, and stannic chloride, we saw that its hydrolysis is incomplete and it reacts with HCl to form cetanic acid. Okay, in next video I would tell you about the compounds of lead.